now, you know that threshold for an excitable cell is roughly around negative 55 millivolts, right? Threshold stimulus means you have to hit a certain voltage in order to get an action potential, or, excuse me, a muscle contracting twitch. The latent period, or the latency period, or the lag time, is a time it takes after you zap a muscle with the stimulus for it to ultimately contract. So think about it. This nerve terminal button gets excited. And then what happens? What happens after the nerve gets excited? How do you get the muscle contracting? What has to happen? Okay, calcium voltage gated channels pop open. Calcium rushes in. Acetylcholine goes where? Into the synaptic cleft. Then it goes where? Binds to, somebody studied, binds to the nicotinic cholinergic receptors and does what to those? Pops them open. What happens then? Sodium rushes in, depolarizes that muscle, the motor end plate, and then what happens? Action potential goes down the T-tubule, activates what receptor? DHP receptor, and causes what to be released? Calcium from where? Sarcoplasmic reticulum. Calcium binds where? Troponin, and moves what? Tropomyosin out of the myosin binding sites on what protein? On the actin. And then what happens? The myosin heads bind to the actin. And then phosphate leaves and contraction. Okay, so from that end plate getting excited all the way to right before contraction, that's the latency period. From when the nerve is stimulating the muscle to when you actually get contraction, all of those events happen during the latency period, or the latent period. Good job, you guys. You studied. Love it. All right, twitch. Twitch is a single brief contraction of a muscle fiber. When we say muscle fiber, we're not talking about the whole organ. We're talking about one muscle fiber, or in fact, one motor unit. A motor unit, remember, is one motor nerve plus all the fibers it innervates. Okay? A twitch consists of the two phases, contraction and relaxation. Contraction, you need calcium and ATP for. Relaxation ultimately is caused by the acetylcholine not being released in the synapse and acetylcholine getting degraded by acetylcholine esterase and the calcium getting sucked back into the sarcoplasmic reticulum. Here's a picture of it. So what happens during lifetime? The nerve gets excited, the terminal button gets excited, and then the muscle fiber has to get excited, and then you get contraction of the skeletal muscle and relaxation. So during when the nerve is excited to when you actually get the start of contraction, that's latency period. And notice it's a couple, maybe 3 milliseconds, not very long. When you tap somebody's patellar tendon a couple weeks ago, how long did it take for them to kick? Almost instantaneously, okay? So that action potential went from one nerve synapsed with another nerve and came back out. So sensory nerve in, motor nerve out, contraction. Very quickly, like nanoseconds. Maybe even like point something milliseconds. So this happened very quickly, okay? Contraction and then relaxation. And this takes a little bit of time for skeletal muscle. Not